So here we're going to do the integral of the square root of 9 minus x squared all over x squared. We can't use integration by parts or trigonometric integrations. We're going to use trigonometric substitution. We see this square root sign and then a something minus x squared. We notice that that's very similar to this. When we rearrange this identity, we get cosine x equals the square root of 1 minus sine squared x. So we want to manipulate this to get it close to this. So what we're going to do here is we're going to make x equal to 3 sine theta. And it's going to be, you'll see it when it plays out. So when we integrate dx, that becomes 3 cosine theta d theta. So now we're going to go ahead and we're going to do some substitution. We're going to plug this into this into this, and this into here. So you'll see it'll become more intuitive as it plays out. So 9 minus 3 sine theta squared all over, and 3 sine theta squared, and then dx is going to be 3 cosine theta d theta. So now when we expand this, we're going to say 9 minus 9 sine squared theta over 9 sine squared theta, 3 cosine theta d theta. Now notice you can factor out the 9, and then you'll factor out the 9, and then there will be a 1 minus sine squared theta. So now we have our little identity over here that we know is just cos theta, or cosine squared theta. And then 9 sine squared theta, 3 cos theta d theta. So then we can separate that into square root of 9, square root of, and this just becomes cosine squared theta, 9 sine squared theta times 3 cosine squared theta. So then this just becomes 3, and this just becomes cosine. And this is 9 sine, and this is 3 cos theta d theta. This and this combined, 3 times 3 is 9, and 9 they cancel. So what you're left over with is cosine squared theta over sine squared theta d theta. And then you can just rewrite this as cotangent squared theta. Now because of the identity, 1 plus cotangent squared theta equals cosecant squared theta, we can just move this over here, and that can just become cosecant squared theta minus 1. And then when you integrate that, this just becomes negative cotangent theta minus theta. Now, we can't just leave it in this form, okay? So this is actually our integral, but we have to go back up here. So when we go back up here, we want to create a triangle out of this. So what is theta? Well, we know x divided by 3 equals sine theta. What's sine? Opposite over hypotenuse. So we're going to say this is going to be x, this is going to be 3. Now, what's this? It's going to be this squared minus this squared, all square rooted. So that's your triangle. So here when we say, well, negative cotangent, well, what's cotangent? If tangent is opposite over adjacent, then cotangent is adjacent over opposite. So we're going to write this as negative this over this. And for just theta, well, what do we know theta is? Well, if sine theta is this over this, then we have to do the inverse of that. So we'll say sine theta equals that. Well, then theta is just sine negative 1 of that. So we'll just put that in there. So minus sine inverse of x over 3. And that is your final answer. It's a lot of work for one problem, but when you integrate, and then you can find out, and this is true.